In the past lessons, we've been learning about percent increases and decreases using doubled number lines. In this lesson, we're going to talk about percent increases and decreases with equations. How do you get from one number to the next using multiplication or division? How do you get from 100 to 106? What you can do is you can use these numbers and arrange them in a fraction so that 100 is increased to 106. So either you would put 100 over 106 or 106 over 100. So you're using those numbers, you're making them into a fraction, and now you need to decide, is it 100 over 106 or 106 over 100? Well, if you look at what's happening to 100, it's increasing, so we want to multiply it by a number that is going to be greater than 1, which is this, 106 over 100. So you're multiplying by 106. And you can simplify that. You can divide both numerator and denominator by the same number. So I'm going to divide both of them by 2. I know they're both divisible by 2. 53 over 50. You do not have to make that into a decimal. You do a similar strategy for the second one, from 100 to 90. So that you multiply by 90 over 100. This time it's going to be 90 over 100 and not 100 over 90 because 100 is being decreased. So 90 over 100 is less than 1. That will decrease 100 to 90. And you could simplify that to 9 over 10. How about from 90 to 100? So from 90 to 100, now we're increasing. It would be 100 over 90 or 10 over 9. And you're multiplying by that, multiplying. How about 106 to 100? And that's similar to the first one, but this time it's 50 over 53 because you're decreasing. Activity 8.2, interest and depreciation. Interest is money that is charged when you borrow money, or money that is paid to you for the use of your money. You can earn interest on money you keep in a savings account, and you can also be charged interest when you use a credit card to make purchases. Depreciation is the process of losing value. So interest is something you are charged when you borrow money. And then depreciation is when you buy something like a car, so that depreciates. If someone buys a car in this year, in 5 years, it's going to be worth less money. That's called depreciation. The first problem was about interest. This problem's interest. And the second problem is about depreciation. Money in a particular savings account increases by about 6% after a year. How much money will be in the account after 1 year if the initial amount is $100, $50, $200, and $125, and finally X dollars? I organized the data into a table, and in my table are columns. First column is initial amount, second column is interest, and third column is final amount. So our initial amounts are $100, $50, $200, $125, and X dollars. X dollars means we don't know the amount, and we can use that X for any amount. The amount doesn't matter. The number doesn't matter. When you use X, that's saying that it could be any amount. So let's add the interest. For interest, interest on $100. Interest is the same, 6%. Interest is 6%. So $100 interest is 100 times 6%. 6% can also be thought of as 6 over 100 or 0.06. So you can multiply any number by 0.06 and that would be 6% of that number. So 100 times 0.06 is $6. This is all in dollars. 50 times 0.06 would be half of the amount above, $3. 200 times 0.06, that would be double the interest on $100, $12. And 125 would be 125 times 0.06. Well, you know that each $25 is gonna accrue. Accrue means it'll get that much interest. It'll accrue $1.50. So our interest for $125 is $7.50. $7.50. And now our interest on X is X times 0.06 or 0.06X. Now that we've calculated the interest for all the principal amounts, we can now get the final amount. So the final amount would be the interest plus the initial amount. It means how much you have in the account to begin with plus the interest. So the final amount here is 100 plus 6, 106. Here it's 50 plus 3, 53. And then for 200, it's 200 plus 12. And then here it's 125 plus 750. And that is 132.50 cents. So what about if your initial amount's X? Well, what you do is you put an X instead of the initial amount. So whatever your initial amount is, you add on your interest, which is 0.06X. And that is your interest. And there's another way to write that. If you could find another way to write that, you can factor out the X. Let me do it another color. But you can factor out the X and make it X times 1 plus 0.06 or 1.06X. So if it asked for an equation for the final amount of interest, the final amount equals 1.06X, where X is the initial amount. Problem 2. This problem is about depreciation. The value of a new car decreases by about 15% in the first year. How much will a car be worth after 1 year if its initial value was $1,000, $5,000, $5,020, or X dollars? I made a table to organize the information. Let's first write our initial amounts, and finally X. Now let's find depreciation. Depreciation is how much money is lost, and it says that depreciation is 15%. So let's calculate depreciation. 1,000 multiplied by 15%. That is $150. So if someone bought something for $1,000 and it depreciated 15%, it would depreciate by $150. If they bought something for $5,000, it would depreciate for $750. Because that's 15% of 5,000. And if they bought something for $5,020, it would depreciate by that multiplied by 1.5. And I'll just tell you what that is. That is $753. And if they buy something for X amount of dollars, now it depreciates by 15% of X, which is 0.15 times X. 0.15X. And now we can calculate our final amount. So our final amount is whatever the item was worth to begin with, minus depreciation. So 1,000 minus 150. $850. The item would be worth $850 after a year, after depreciating 15%. And if you bought it for $5,000, it would be $5,000 minus $750, which is $4,250. And if you bought it for $5,020, it would be depreciate by $753, and it would be worth $4,267. So try the X by yourself, because the X doesn't require arithmetic, but it does require you to think about manipulating variables without numbers. So how would you write the final amount if the initial amount was X? Well, you would write the initial amount minus the depreciation, which is 0.15x. And you can rewrite that. You can factor out the x. So it'd be x multiplied by 1 minus 0.15. And then you could simplify that to x times 0.85. And you write the decimal first. So 0.85 times x. The variable is always after the coefficient. So your equation would be final amount equals 0.85x, where x is the initial amount. There's a lot of organizing numbers with these problems, and it's often like that with finance or accounting. There's a lot of tables, a lot of number organization. Activity 8.3, matching equations. Match an equation to each of these situations. Be prepared to share your reasoning. Number 1, the water level in a reservoir is now 52 meters. If this was a 23% increase, what was the initial depth? For this problem, I would focus on the increase or decrease part. So this is increasing. It's a 23% increase, and now gets to 52. So whatever the initial amount is, it has to get greater to 52. It looks like if you look at the equations, x is our initial amount, so x has to be increased to 52. And the only one, there's two that's increasing, so it's either this equation or this equation that's increasing. The other two are going to be decreasing, because this decimal, 1.23, is going to be increasing x. Sort of like we saw in the previous problem with interest. When you're getting interest, it'll increase. So increase the x to 52. And that would make this equation r increasing to 52 meters. How about number 2? The snow is now 52 inches deep. If this was a 77% decrease, what was the initial depth? So now we are decreasing, and the two decreasing equations are this one and this one. So those two equations are decreasing our initial value x. Because these two decimals are less than 1, they're going to decrease the value of x. This one is a little confusing, but if it decreases by 77%, it's actually going to be 0.23x, because 1 minus 0.77 is 0.23. And that's what you do when you decrease something. You're going, just like the depreciation is 1 minus the rate, it's 1 minus 0.77. Activity 8.4, representing percent increase and decrease equations. First, let's revisit the number line from the previous lesson with gas gallons. So gallons of gas and percentages. The gas tank in Dad's car holds 12 gallons. The gas tank in Mom's truck holds 50% more than that. How much gas does the truck tank hold? And if you remember from last lesson, we used this number line to calculate how much gas the truck holds. This time, we're going to use an equation. Explain why this situation can be represented by the equation 1.5 times 12 equals T. Make sure that you explain what T represents. I'm going to rewrite the equation with T on the left side. T equals 1.5 times 12. And now we can explain this because we learned about increasing with interest, but increasing applies to other areas with percentages as well. So 1.5, the 1 is the initial value, and the 5 is the percent increase. 5, so that's 50% increase. Even though it's 1.5, it's 50% increase because 0.5 is 50 over 100. And 0.05 is 5 over 100. That's a little bit confusing, but 0.5 is actually 50 because that is in that tenths place. So let's go back to our equation, and the 12, you're multiplying by that's the amount the car can hold, the amount of gas, the gallons, and finally T is the gallons that the truck can hold. Number 2, write an equation to represent each of the following situations. A movie theater decreased the size of its popcorn bags by 20%. If the old bags held 15 cups of popcorn, how much do the new bags hold? B, after a 25% discount, the price of a t-shirt was $12. What was the price before the discount? And C, compared to last year, the population of Boontown has increased by 25%. The population is now 6,600. What was the population last year? Question 2 is asking to write an equation to represent each of the following situations. Writing an equation can sometimes be tricky. It's important to look for key pieces of information in the story so that you can accurately represent it with a model. A movie theater decreased the size of its popcorn bags by 20%. If the old bags held 15 cups of popcorn, how much do the new bags hold? First, we have one key piece of information is a decreased size of its popcorn by 20%, and then the old bags held 15 cups of popcorn. And finally, we need the new bags, which is unknown. So we write the key pieces of information. I like to write them in chronological order. So in the middle, we have the decrease by 20%. And first was the old popcorn, which is 15 cups. And then after the decrease, so old popcorn, decrease, and then new popcorn. And that's unknown. We'll call that X. So first old popcorn, then the decrease, then the new popcorn. Okay, so now we can write our equation. And equations have equal signs. So let's start with an equal sign. And on one side, we'll put the old popcorn. And the other side, we'll put the new popcorn. So we need to do something to the old popcorn to get to the new popcorn. Well, we decrease by 20%. And a 20% decrease, you might think to multiply the 15 by 0.20, but that's not a decrease by 20%, that's taking 20% of 15. We want to decrease 15 by 20%. So just like the depreciation, we saw depreciation was 1 minus that 20%. 1 minus 0.20, which is 0.80. So if you multiply the 15 by 0.80, that is decreasing 15 by 20%. And that's our equation. B, after a 25% discount, the price of a t-shirt was $12. What was the price before the discount? So let's write it in chronological order again, the story, I mean. And first we'll start with the 25% discount. So that's a decrease by 25%. And the original price was, we don't know. So the original price, let's say old price. We don't know. So X. And the new price is $12. 1, 2, 3. First was the old price, then the decrease, and then new price. So let's write our equation. I'm going to use green this time. Start with an equal sign. And this time our old price is X, so that's on the left side. I'm going in chronological order left to right. So old price, and the new price is 12. So we need to get our old price to 12 by decreasing it. And a decrease, you're not just multiplying the percentage as a decrease. The decrease is has to be 1 minus the percentage. 0.25, which is 0.75. And we're decreasing the original value, which is X. So 0.75x is 12. And that is the equation for the t-shirt discount. If you decrease something by 25%, you're taking 75% of it. That's the idea behind this equation. C, compared to last year, the population of Boomtown has increased by 25%. The population is now 6,600. What was the population last year? So let's get our key information. This time it's an increase by 25%. So increase 25%. The old population is unknown. Old population, that's X. And then new population is 6,600. So 1, 2, 3. That 1, 2, 3 is for the order of the story. And let's use red this time. So I'll start with my equal sign. And old population, so that's unknown. And then our new population is 6,600. And this time we are increasing the old population by 25%. Well, just like when you increase for interest, you add that to the original amount. So it's 1 plus 0.25. And if the 1 plus 1 minus is a little confusing, go back to the interest and depreciation and look at that part of the video and then play around with those numbers. Because if you're increasing, it's 1 plus the percentage, and then if you're decreasing, it's 1 minus the percentage. 1.25. And now you're going to take 1.25 of the old population. So 1.25 x is 6,600. And that is the equation for increasing the population. Lesson synthesis. What are some ways we have learned to solve percent increase or decrease problems? Well, we used equations and we used double number lines. Which representation do you prefer to use and why? Personally, I like equations better, but sometimes I like to use double number lines in some situations.